From a simple calculator to a portable multimedia box, the definition of computers has gone through several changes. We are in the age of powerful computers known as supercomputers. They are used in scientific and engineering applications and can perform very high-speed computations of some of the biggest mathematical problems that can take the human mind several years to solve. Stanley Penn once said, despite the trends to compactness and lower costs, it is unlikely everyone will have their own computer anytime soon. Well, now we have computers in our hands as smartphones. Today's world is completely dependent on computers, and this dependence is only going to increase with the advent of automation and artificial intelligence.
Peace in our time.
From room-sized computers to palm-sized smart devices, increment in memory storage and reduction in size of memory devices, and development of tiny integrated circuits enabled manufacturers to build highly advanced computers. But how will computers proceed into the future? What new technologies will be introduced? Let's talk about the future of computers. My name is Siddharth, and you are watching The World of Science. According to Moore's law, the number of transistors that can be packed into a given unit of space will double about every 2 years. The reduction in the sizes of microprocessors means that more such processors can be packed inside a computer chip. More processors means more separate operations can be performed by them simultaneously, and thus to solve a problem, computers get more helping hands in each successive generation. Reduction in sizes of memory devices results in increase in the memory storage in a computer system that can be used to store a large number of permanent files in ROM and temporary files required for smooth operations in RAM. The flexibility and availability of computers has been increasing exponentially, and we are in the golden phase of computer evolution. Many scientists believe that this exponential growth will lead to a future where computers will attain human-level intelligence. Do you know what's equally important as the future of computers? It's the future of our nation, and that's in the hands of young minds. We live in a country where every other kid aspires to be a space pioneer. But these kids do not have enough opportunities to learn, implement their skills, and execute space missions. Introducing STAR, a space education and space launch service-based startup that aspires to make space accessible for everyone. STAR develops rockets to provide quick and affordable access to space. STAR is building a sounding rocket named Kalam to launch experiments to space at a very affordable cost. STAR is not only building rockets, but also uplifting young minds by providing them project-based learning and hands-on learning experience on space tech through their masterclass and training and internship programs. The masterclass is a series of live sessions conducted online to provide learning experience on basic and advanced concepts of space-based technologies such as rockets, satellites, and rovers. STAR sees the future where young minds will not only study space by sitting in the classrooms, but also send their experiments to space. Find out more about STAR from the link in the description below. Now let's get back to our video. American inventor Ray Kurzweil had predicted that the computers will achieve this human-level intelligence within 2 decades, probably by the end of 2020s, when scientists will successfully reverse engineer the human brain. A normal human brain performs about 10 to the power 15 to 10 to the power 30 logical operations per second. Scientists although disagree on exact numbers. This logic is as per the Moore's law that by 2030s we will be able to pack as many processors in a small space that can perform as many operations as that of the human brain, and this will allow computers to become self-learning and capable of adaptations and iterations with the initial self-learning program installed in them. In this process, the input data is provided through different channels and is passed through various intermediate nodes. At these nodes, the input data is processed through a mathematical function, and finally an output is generated. That output is compared with a standard value, and any change in them is sent through a feedback loop back to the nodes, where the machine will adjust itself and produce an output closer to the standard value. The process is iterated several times until a perfect output is obtained. This is a simple example of a closed-loop learning program's functioning. Thus, a computer with more microprocessors will be able to perform such multiple iterations efficiently and with faster speed, thereby providing the result in real time. But the process to achieve brain-like complexity is not that simple, and many brain scientists differ with the view that computers will ever attain such intelligence. For more information about artificial intelligence and how we can create an artificial life, do check out this video. Also, as the size of transistors keep on decreasing, it will certainly reach some point at the quantum level where the laws of classical computing won't apply. At this point, there is a saving grace known as quantum computing, which can use the quantum properties to manage the calculations at the quantum level and can perform more operations than any modern supercomputers. Quantum computers store the data in a qubit. The qubits are entangled photons where a change in the state of one particle affects the change of another entangled particle. In classical computers, we deal in either zeros or ones, but in quantum computing, qubits can take the value of 0 and 1 simultaneously due to property of quantum superposition. In December 2020, scientists at the University of Science and Technology of China performed a calculation in a photonic quantum computer that generated the results in 20 seconds, which a classical computer could have taken 600 million years of computation. This advantage of quantum computers over classical computers is known as quantum supremacy, and if implemented on a large scale, this will change the scenarios of computer technology completely. MIT professor Seth Lloyd calculated an upper bound for a 1 kilogram computer in a quantum state that can perform 5 into 10 to the power 50 operations per second, while an Earth-sized classical computer can solve only 10 to the power 42 operations per second. One can easily compare the level of advantage a quantum computer has over classical computers. One step ahead, if we want the computers to reach the human intelligence level, we have to create a carbon-based biological neural network that behaves exactly like a human thinking machine and passes the Turing Test, which is a method of inquiry in artificial intelligence for determining whether or not a computer is capable of thinking like a human being. To achieve this, there should be fine detailing at the level of synapses. Just like our brain is made up of billions of connected neurons, an artificial neural network is an arrangement of such nodes interconnected to each other where at each node a mathematical operation is performed. The more complex the network, the more precise will be the solution, and if combined with self-learning programming, human-level intelligence in the near future is very much possible, at least theoretically. Nick Bostrom, a Swedish philosopher with a background in theoretical physics, computational neuroscience, and artificial intelligence, went a level ahead and proposed that it is even possible to simulate the entire human civilization with computers. For 100 billion humans lived throughout history, each living approximately 50 years of life and each human brain performing 10 to the power 14 to 10 to the power 17 operations per second, would require a total of 10 to the power 33 to 10 to the power 36 operations per second, and that is possible to generate with quantum computers. We have explained the computer simulation theory of the universe in this video. Do check it out. With artificial intelligence, neural networks, and automations, computers will change the nature of human society in the coming years. This change will be more significant than the Industrial Revolution. Technology is evolving with each passing day, and many new revolutionary developments have already happened in the field of computer technology, which we will cover in the upcoming videos. So, what are your thoughts about the future of computers? Let us know in the comments. Also, don't forget to check out the masterclass and virtual training programs by Star in the description below. If you found this video interesting, please leave a thumbs up and share it with your friends. Do follow us on Instagram for daily quality content that'll make you fall in love with science. Make sure you subscribe to the World of Science. Until next time, stay scientific.